Here I'm taking out the screw by hand with the X-axis table. Doesn't really take that long. Taking out this way just looks like it'll be easier to get this apart. I think I might have to unbolt my base from this wooden board, so I can undo. There's a Allen head screw right here, and I think the table will just slide off, I hope. Okay, just keep unscrewing it, and then she comes on out, and then she's got this little brass piece on there. Just leave that on there, don't want to lose it. Taking this off because it's kind of like a stop for the table. It won't slide all the way off. Coming. And she's off. Here's the X table. Done. Okay, now I got to take off the Y-axis screw from the bed here, and got to screw it, in this case clockwise, to get it all the way out. And there are two nuts that hold it in place. A little black brass star nut here that slides off once it gets off the first nut inside here. So, okay, now we'll take off this stop screw of the bed piece. And we'll slide this one off. Maybe. Very stiff. Of course, I've already loosened the lock nut on the side of here, so that's not slowing me down. It's just stiff. Oh, they've already knocked that one. They're just loosely in there. There we go. Got her. Okay, now I'm going to try to remove these Allen screws here, holding the Z-axis column in place. Tried to quickly pull one of them off earlier, and it was amazingly tight. Let's see how this goes. Oh my gosh, it's tight. Oh, wow. You see, when they give way, they pop. Took a lot of force. Of course, I'm gonna have to worry about, I think it's called tramming the mill when we get this back together. There's probably just a tiny bit of play in the column here, and I'll have to make sure that it is true or perfectly vertical in 90 degrees to the bed. There we go. Got the Z column off, and we'll clean that up before we put her back on. I guess we're gonna for the same reasons, we want to go ahead and so put our screws back first. Where they go. And I got to take these Allen screws off here. So I'm going to take this off because I want to be able to clamp this base, and this will be in the way. Okay, our instructions tell us that we got to bolt the template block, the little rectangular block. This little guy got 3 little holes on it. We have to bolt this to our base or our table, and I believe we use this other cylindrical shaped template will be used for the Z-axis column. Okay, now that we've bolted this little template block to the base, we want to make sure it's parallel. This surface is parallel with the base surface. That way our screws will be nice and true. The instructions suggest that we clamp it, but I'm not clear how I should clamp it. I mean, a long clamp this way is a really big clamp I don't have. Probably cover one of the holes. Clamping it this way, I'm not sure. Clamp here, but I'm not sure that will guarantee it will be flush. So what I came up with was there's a little bit of a depth. Here we go. Difference between this surface and this surface, and I measured that with my happy little digital calipers here, and I came up with 0.08. And it just so happens I happen to have some 0.08 thick aluminum sheets, and if I put that there, that will give me a flush surface here. And if I then clamp, let's say it's like cocked like that, if I clamp another heavier stock of aluminum to that surface, one on the other side, just so I don't mar up my surface. If I clamp that in place, then that should keep this nice and true and from rotating as I drill those holes out. Okay, here it is, all ready to clamp into the drill press. I cut a couple chunks of aluminum, thick stock, for sort of clamping. That way it'll be at least aluminum, clamped to aluminum instead of steel. So I don't want to get any marks on my nice base. You can see how I did this. See that little tiny shim there, the exact covers that distance, and then that keeps that square. Alright, here's my drill press. Woodworker's stand-up drill press. This might be a little bit overkill, I'm not sure, but I just don't want to make any mistakes. And you can see I've got the hole set up here in the drill press, bolted to the table. Everything appears to be pretty squared up, as square as I can make it, I guess. And we're going to go ahead and drill these holes. Alright, there we go. We got the holes complete for the base. And for the X table, to put the template on there, I had to come up with a couple of little plastic shims and a sheet of aluminum cut there to cover that distance so I could square that up. And I tightened down the nut, the little screw, and then I measured it and made sure it was square. And I clamped it with this little vice grip. Seemed to do the job. We're in the base, all ready to drill and tap again. Okay, now we're ready to do the Z-axis. Have the template on, as per instructions. And we're going to go back to the woodworking drill press and drill that out. Well, we drilled the steel Z-axis, and I was really quite surprised how easily it cut. I thought steel would be a lot harder to cut, but I think that's probably more likely to do with the fact that I was using a very high quality tin plated drill bit. It was kind of expensive, but it really cut. It made it feel like I was cutting even easier than aluminum. Plus I also made sure I used the new and improved Tap Magic cutting fluid. I think that really felt slippery too. So, and the tapping is going quite well also, kind of surprisingly. You can see there that it's just cutting right down really well. And I like this tap as well. You'll see it has two cutters or threads and only two grooves. The other ones I was using for the aluminum has 4. You can see that. It's just 4 threaded and 4 grooves. And I don't think that does as good a job, so I'm definitely going to get this style from now on. And here it is, my Sherline mill parts, all ready to go back together. Did a little cleanup on them. All the main parts are now drilled and tapped and ready to go. Well, now I think I need to grease the slides here. They originally had a little bit of grease left. It was kind of dried up. But after I cleaned it, now there's nothing on it, so I think I'm gonna use this Super Lube synthetic grease. It's nice and has a nice clear consistency. Okay, now we're ready to put the preload nut on. That's this little guy right here. And notice there's like a cup. One side is sort of flush, and the other side has a little cup. And the cup faces outward. It's very hard to tell, but if you look at the little diagram there, you'll be able to see that the cup faces outward. And you need to use either the left hand or right hand nut. Well, I made sure I kept the screws separate. I took this one off last, so I knew it went back on first, and it happens to be the left hand screw, so it takes a left hand nut. Now we need to put the motor mount. Make sure the inner bearing and outer bearing are seated well, and just slide it on. There's what they call a coupler. I just slid that in there. You can see it maybe a little better here. The light here. There's our coupler inside there. Slid that in with a little tiny Allen screw. And to tighten the Allen screw, use our Allen wrench. And there's another little Allen screw on the side of the shaft. We don't need to tighten it, but we put another Allen wrench here through that hole into the coupler, and that holds it in place while we tighten. And that'll tighten the coupler to the lead screw. And you'll see here we have our what do you call it, preload nut in place. I'll put some Loctite on there. Just use the capillary action as it said in the instructions, so let the Loctite seep into the threads. Hold the preload nut in place. Here's the stepper motors that came with the Xylotex. I'll stick it on there and bolt it on. Okay, here we're installing the last stepper motor. As soon as I would tighten the saddle, then turning the Z-axis thread became extremely difficult. Even though this was sliding well on the dovetails, the screw became, it's almost like it was being pinched. Fixing the adjustment had to do with this screw and that screw. And tightening or loosening those would cause it to pivot this thing either this way or this way, and that's what was causing the pinching. It was an amazingly small amount that it took to adjust this and this to take that pinch out and allow that screw to travel freely. And so now I can move that dovetail up very smoothly now without a lot of pinch. So that fixed that. Now on to the next step. Another very useful tool was to take this 1/4 inch drill bit, cut off the shaft of it, and then you could stick it into the hand wheel. Then I could take that hand wheel, stick it into the lead screw and then I could adjust it, and there you go. I've got the Z-axis backlash adjustment complete. Well, we're getting close. We got all 3 main axes with stepper motors loaded up. Still got to put the 4th axis on the rotary table. Otherwise, she's looking pretty cool.